Hello Hayden, this is Miss Tracy. So we are in lesson 115. So it asks us first to graph x is less than -2. Well, the first thing that we need to do in order to graph this is to graph it as the line x is equal to -2. So that's the line we're going to graph. But we're going to graph it with the dots because there's no equal sign underneath this inequality. So we're going to find -2 on the x-axis, on the x-axis we've got -2, and we are going to just dot it in, just like that, because it's crossing the x-axis. Then that is what we are going to do. Okay, I am going to take this out because we don't need this anymore. Now that we've got the line graphed, we go back and look at the inequality symbol. And it says x is less than -2. Well, on the x-axis, numbers get smaller as they go to the left, to this side. So for it to be less than that, it has to be all the values over here. So we just squiggle in all the values over here. That's the answer. That's what we're doing with these. Let's look at the next one. All right, so this one says y is less than or equal to 3x minus 2. So we're going to graph the line 3x minus 2, where -2 is the y-intercept. We have the little equal sign here that tells us to make a solid line. So I'm going to make a solid line. We'll start at the -2. I'm going to look for my slope. My slope is 3, so that's going to be 3 over 1. So it means up 3 over 1. So up 3 over 1, up 3 over 1, which is going to be something like this, and then to here. And then if there was another dot, it'd be right about here, so that would cross about here, right? So I'm going to come right to there. Now, it says y is less than 3x minus 2. So on the y-axis, the points that are less, that get smaller when you go to the negative side of the y-axis, right? -4 is less than -1, right? -4 is less than +2. So we're going down. Down is less than. So we want the points that are less than. So it'd be all of these. Okay? Less than means below the line. Greater than means above the line. So let's look at the next one. Y is greater than. So greater than, we're looking for points above the line, and it is or equal to, so it's a solid line. So I look first for my plus b, my y-intercept. That's going to be +1, so put my dot here. And now I look for my slope, which is 1 over 2, and it's positive, so that means it's up 1 over 2. So up 1 over 2, up 1 over 2, and I'm going to kind of work that way backwards to get a straight line. And I'm going to just connect the dots. That helps me draw my line better when I just connect the dots. Okay, so there's my line. It's a solid line because of the equal sign, but now it says y is greater than. So that means I need the points above. I need the bigger numbers on the y-axis. So that's going to be all of these points up here. And that's how you would graph that. All right, so now this says y is greater than x. Well, if y is greater than x, if this were a line, it would look like y is equal to x, which means that whatever value y has, x is the same. So that means if y is 0, x is 0. Y is 1, +1, x is +1. If y is +2, x is +2. 3, 3, 4, 4. So it's going to split the Cartesian coordinate system exactly in half at a 45-degree angle, because the value of y is equal to the value of x. So where those numbers match, that is where your line is, okay? So that's how we graph the line. Sometimes just using the equal sign there helps you see what to graph. There is no line underneath it. So we're not going to connect the dots. Instead, I'm going to go back with just a few more dots in between, just so it's clear that this is the dotted line. Okay, so there's my dotted line, and it says y is greater than. Greater than means above, so it's all of the points above the line. Just like that. Okay, next one. All right, so here we have y is less than or equal to, so it's a solid line, x plus 1. Plus 1 is our y-intercept, so positive 1, we put a dot. Now, there's no number here in front of the x, but we know when we have a variable by itself that the number here is an invisible 1. So that means it's 1, right? So if it's 1, then we turn that into a fraction for slope, 1 over 1. So that means it's going to be up 1 over 1, up 1 over 1, up 1 over 1, and then in reverse so that we can make our dots, and then we can just draw a line from dot to dot. That makes it easier to draw the line that needs to go there. And I'm going to erase this because we don't need it anymore. Now it says y is less than that line, so we're going to do all of the points below because less than means below. Just like that. All right. Now here we have x, so we're dealing with the x-axis. X is less than -5. So there's no line, so it's a dotted line. So because it's -5, it doesn't matter what y is. X is always -5. So it means we have a line right here, right? But it's no solid line, so it's a dotted line. So I'm just going to dot everything on this line right here, just because that makes it easy for me. Okay, so there's my dotted line. And if x is less than, I need to go to the less than side, or to the negative side. So that's going to be like this. So all of these points here, all these values here on this side of the dotted line. Okay. Now I think the next one that you had problems with was this one, where it says to factor 9x squared plus 6x plus 1. So let's go over here to my other program. All right, so 9x squared plus 6x plus 1. We got to factor that. So one of the things that I see is that it has a coefficient here, and we can't factor it the regular way because it has a coefficient, because I've taken into account that this is going to be multiplied by something. So what I need to do is I need to multiply this number by this number. When I do that, I get 9. Now I need to look at the factors of 9 that when added together equals 6. That's pretty easy. That's going to be 3 and 3, right? Positive 3 times positive 3. So now I can rewrite this. 9x squared plus 3x plus 3x plus 1. All right, because 3 plus 3 is 6. Because these two, when added together, makes a 6x. So we haven't changed the value of the expression at all. We've just split it up. Now I can factor. So the thing that I see in both of these terms is a 3x. So 3x comes out of 9x squared, and it leaves behind a 3x. 3x times 3x is 9x squared. And 3x times 1 is 3x. So 3x times 3x plus 1. Now we have plus 3x plus 1. There is absolutely nothing in common with both of those terms that I can factor out. Nothing. So when there is nothing in common with the terms, you do this. 3x plus 1 plus 1 times 3x plus 1. When there is nothing in common, you just group it together and put a 1 in front of it. You're just multiplying it by a positive 1. But look what happens when you do that. You have identical factors here, right? So we can put them together as one factor, and we can group these two factors together as well. So we end up with 3x plus 1. That's this 3x plus 1 times 3x plus 1, because that's what we have here with each one of these. So this is going to be our factors. 3x plus 1 times 3x plus 1. The key thing is when you have absolutely nothing in common, multiply it by 1. Or factor out the 1. Because even though there's nothing in common here, it's still 3x times 1 plus 1 times 1. So they still have a common factor even if they don't have any other factors at all. It's always going to be 1 if there's nothing else there. All right, let's look at the last one you had problems with. All right, this was the last one that you struggled with, was find m. We have x over m minus c over d equals d. So let's go over here. And we're looking for m. So we got to solve for that. So the first thing I would do is find the common denominator and then multiply everything by the common denominator. And that common denominator is going to be MD. So MD times x over m minus MD times c over d is equal to MD times d. So the m's cancel first, so we get dx. The d's cancel second, so we get mc. And then the d's here are squared, so we get md squared. So now I can add this term to both sides. This would cancel, so I get dx is equal to md plus mc, or md squared plus mc. Now I can factor out the m. Dx is equal to m times d squared plus c. Okay. Now I can divide both sides by d squared plus c, d squared plus c. So this cancels. That means that m is equal to dx over d squared plus c. This is what you would type in. All right, that's all of them for lesson 115. Since we're only about 13 minutes in, I'll go ahead and do 116 in the same video. All right, so it says this is lesson 116. Bustles were just not selling, so Julie marked them down 40%. So the sale price would be $3.60 each. So what was the price before the sale? So remember we did percent times a number is equal to a different number, P times A equals B. We're going to apply that here. So she marked them down 40%, so the sale price would be $3.60 each. Well, if she took 40% off, then the sale price is 60%, right? So that means we've got 60% times some number is equal to $3.60. So we turn this into a decimal. That'd be 0.6 times A is equal to 360. Divide both sides by 0.6. Let me pull up my calculator. 3.60 divided by 0.6 is $6. So A is equal to $6. And that's how you do that problem. You could also look at it with your proportion statement and say, okay, if the markdown is 40%, the total price was 100%, that means that what they sold for was at 60%, because 40 plus 60 is equal to 100. So the dollar amount for what they sold for is $3.60. So I'm looking for my price before the discount. So then you could say 60 over 100 is equal to 360 over X. It's going to be the same exact answer. We divide both sides by 60. X is equal to 6. So you can do it either way. Setting up the table, it gives you this part right here very clearly and plainly and helps you with the logic of it. But if you can do this part right here, if you can get to this point without skipping it, like if you put the 40% here, you would not get the right answer, right? You've got to put 60% here. So if you can't see this, do the table, right? But if this occurs to you normally that, oh, well, this is the markdown. So that's the markdown is not what you pay. It's what's left is what you pay after they take the markdown off. So you got to take the markdown off of the original price to see what they actually paid. And they paid 60% of the original price, which is why we said 60% times the original price gives us $3.60. So you got to think it through and understand the logic behind the problem in order to put the right number where it needs to go. And the table can help you see that a little bit more clearly. It's an extra step. And if you don't have to do it, that's great. But if you need to do it, do what you need to do so that you can get the problem correct, so that you can understand what's going on. All right, so let's look at the next problem. So here we have another graph. Y is less than or equal to, so it's going to be a solid line, X minus 3. So first off, we are going to mark the negative 3 on the y-axis. And then we're going to realize that there's an invisible 1 in front of the x. That's our slope. So 1 over 1. So that means up 1 over 1, up 1 over 1, and so on, and so on, and so on. And we'll go back in the same direction, just filling that in. And I'm just going to make my little dot right here, my dotted line. Just tapping the screen. It's fairly easy. So there's my dotted line. If y is less than, actually I'm sorry, that is a solid line, isn't it? That's less than or equal to. So that means that I can connect the dots. And that's fine. As long as you remember to connect the dots when you see that, do the dots and then make a decision. Sometimes that helps. All right, so now that I've got the line in there, if y is less than, that means we're talking about below. Less than is below. So I'm going to fill in my squiggles to indicate that it's all the points in this area of the graph that make this equation true. So look at the next one. This is to use a graphing calculator to graph y is equal to 1/3 the x degree. Then sketch it below. Make sure to put a point on the y-intercept. So I like to use Desmos, and you can get it online. It is a free app that you can put on your calculator. I think I talked about it in the video. But you can also get it on your computer. And this is it. So what I'm going to do is I am going to say y is equal to 1/3 x. So I'm going to type that in. Y is equal to, and I'm going to hit this little keyboard button down here to show the keyboard. I'm going to click my parenthesis, and I am going to do 1 divided by, and it automatically turns into a fraction, 3. And then I'm going to, then I'm going to do my parenthesis, and then I'm going to do AB for my exponent, and I'm going to put X in my exponent. And if you look, it graphs it for me when I do that. So now all I have to do, I'm going to hide my keyboard now. I'm going to zoom in, got your plus or minus here. I'm going to plus until I see what point that is, okay? So there's a point, 0, 1. So I'm going to go back over here to Jupiter, and at the 0, 1, I'm going to put a dot, just right there. I'm going to go back to Desmos, and I'm going to zoom out. And let's see. Where's a good place where it crosses? Okay, so right here at the 3, it crosses the -1. So that's another good point to see, right? So I'm going to Jupiter. At the 3, it crosses the -1, so I'm going to put a point here. Now I'm going to look at the other side, and I'm just going to move it over. And it's not until it gets past the 3 that it's almost touching. So that's what I'm going to look at over here. I'm going to make sure that I go to here with my curve. Now I can curve it. I can kind of go like this. I can go from point to point, and then from point to point, and then I'm going to just make a little arrow and another little arrow, and that's all I need to do. So this is my y-intercept. Make sure you have the point on the y-intercept. So that's how you use the graphing calculator to tell you how to graph these exponential equations. You just type it in, just like that, using the little keyboard that it gives you, and then you just have to copy it. That's all you have to do. And you can drag it around, zoom in, zoom out, until you see what you need to see. You can see this point right here. -1 and 3. So it is an actual point, -1 and 3. So you can keep looking at the points for the size of the graph that you have so that you can have it more accurate. All right, and that's all you need to do. So let's see if there's another one. I think, if I remember right, it was the last 3 problems. So this is one that you had a problem with. So let's just copy these over. Okay. All right, we're going to use the calculator to solve 4 decimal places. Solve to 4, F-O-U-R, decimal places. So let me pull up my calculator. All right, and I'm going to bring up my scientific calculator. And all I'm going to do is type this number in and put it to the exponent of 2. So 2.718 exponent of 2. And it's 7.3875. That's the 4th decimal point. This is the next one. The 5th one is a 2. If it's a 2, it does not round this number up. So we stop right here, 7.3875. That's what I'm going to write right here. Let me erase this so that you can see. 7.3875 is what would go in there. All right, so now we're going to do this one. Same thing. We press clear. 1.414 times itself. We're going to find the 4th place. 1, 2, 3, 4. This 9 is big enough to round this up. So we're going to put in 1.994. Because, oh, sorry, I missed the 9. Should be 3 9s. And then a 4, because this 9 will round this 3 up to a 4. So now, we're going to do this to a decimal exponent. 2.718. And you see this little XY button here? I did show you this in the video, so you pay attention to the video. You click this, and then you type in any exponent you want, and it's 3.14. And when you hit equal, then it gives you the answer. So 1, 2, 3, 4 places. The 4 is not big enough to round this up, so the answer is going to be 23.0963. 1, 2, 3, 4 places. 1, 2, 3, 4 places. 1, 2, 3, 4 places. And that's what you do. That's how you would solve those. Okay. All right, let's look at the next one. Okay, so this one's a doozy. So we're going to copy and paste it just to make life a little easy so that it is copied exactly and I don't miss anything. Make it a little bit bigger so you can make it easy to see. All right, so here we're going to go through and we're going to simplify first. So the first thing I'm going to do is all the exponents within the parenthesis. Okay, parenthesis first, then the exponents. So I'm going to do the exponents inside the parenthesis. So this would be 1. This would be 4. This would be 8. And then this would be -4. Oh, I'm sorry, it wouldn't be -4 because the negative is included. It would be -2 times -2 would be +4, right? So now I'm going to rewrite that so we can see it. -2, -1 minus 4 times -8 minus 2 plus -2 minus -3 times 4. There's our bracket. All right, now we've gotten rid of all the exponents on the outside. So now we're going to perform the operations inside the parenthesis. So -1, -4, that's going to be -5. -1 minus 4. -8 minus 2 is -10 plus -2. And then in this bracket, I've got negative times a negative. That's going to be a +3 times 4. Okay. All right, so now we're going to do the multiplication that happens next. So -5 times -10, that's going to be 50. I don't know why I made a bracket there. Should be a parenthesis. Plus -2. And 3 times 4 is 12. So 50 plus -2 is the same thing as 50 minus 2. So it's -2 times 48 times 12. I'm going to pull up my calculator to help me because it will do it faster. So 2 negative times 48 times 12. That's going to equal -1,152. And if it doesn't take it like that, try -1,152 without the comma, because sometimes it doesn't have it at both ways. All right, and let's see. I think you have one more. Yes, all right. So this one says to find the surface area of the sphere whose radius is 8 inches, and it gives you the formula, 4 pi r squared. So you don't have to guess, right? So we're just going to use this formula with this radius in order to find the surface area. So let's go over here, 4 pi r squared, 8 inches. Four pi r squared, and r is equal to 8 inches. That's the radius. So 4 times pi times 8 inches times 8 inches. So it's going to be 4 times pi times 64 inches square, and 4 times 64, I can't quite do in my head. 4 times 64 is 256. So 256 pi inches square. That's your answer. You just have to follow what it tells you to do. That's all you have to do. It gave you the formula to use. You just had to drop the 8 inches into the radius. right? And then we did that. So radius square is 8 inches times 8 inches, 64 times 4, 256 pi inches square. Trying to solve for pi, if you keep putting that 3.14 in there, you're making it harder on your life. I don't need it. I'm not asking you, in fact, I'm asking you to stop solving for it. That's what's tripping you up, I think. Quit putting 3.14. We don't care about 3.14 because 3.14 is not pi. It is a rounded, shortened version of pi. It's not pi. Pi is infinite. It's 3.14156789134. It's not repeating, and it never ends. You can round it, but it's not really close to right. You can get close, but you're never ever going to be exact. So just leave it. Leave it like the symbol, and then the symbol is exact. It's precise. It's exactly what you want it to be. All right, and then you can do it in your head, and you don't have to worry about, doing so much work. All right, that's all for lesson 116, and we did all of 115 already, so that should be all of your questions you had so far. If you have any more, please let me know.